this video I will demonstrate how we can use Kubernetes together with Cilium, and I will create a small hello world service that demonstrates how this works in Kubernetes. I've brought up an CGX 2.4 machine, an x86 machine here, which is represented by this white window here, this terminal, and we have this dark terminal is my host machine. That's where we will just check the how we can access the service once it's up and running. So we will do most of our work in this white window here. So first of all, I have created a configuration file that sets up some basic stuff for Cilium. We will use this configuration file when we start Kubernetes. These are some settings for the controller manager and for the API server. So to make use of this, we first need to switch off the swap on this machine. Completely necessary, otherwise Kubernetes will complain, even though we have built it without the swap at all, which is a bit weird, but that's how it works. We will mount the BPF type file system. This is optional, but since Cilium uses BPF, it can make use of this mounting, and this is a mounting that we could do on all the nodes in a cluster. In this case, we only have the master nodes, we only do it here. We set up a forwarding rule with IP tables, and then we can start our Kubernetes cluster. And you see here that we use the configuration file that I just showed you, that one needs to create oneself. And as usual, this takes a while Kubernetes starts up. If Kubernetes hasn't been started before on the machine, it will take even longer, much longer, because all the Docker images need to be pulled in that case. In this example that we run now, we already have the images in our machine, so it doesn't take more than a minute or so. Okay, so now it's up and running. Here it tells us what we need to do to get started before we start using our cluster, and then it tells us how to join other nodes to this cluster. We won't do any of these today. Since we're root users, we can just do an export of kubeconfig variable to point out this configuration file instead of doing this big part up here. So that's what we're going to do, and we're not joining any slave node today. What we can do is to take a look at the manifest files for kubecontroller. Let's do it like this. We can see here that our settings that we added in our configuration file that I showed you before, the kubeadm config file, have been included in the configuration for the Kube Controller Manager. So these manifests files basically are used to start up the Kube Controller Manager and the API server and so on. So the parameters that we set in our configuration file ended up here, which is good. So now when we have started our cluster, we can check what pods we have. And you can see that we have the etc daemon running. We have the API server, the controller manager. We have DNS servers too, but they are not running yet because we haven't deployed any container network solution yet, and that's what we're going to do with Cilium. So these are still waiting for a network solution to be available. We have the Kube proxy and the Kube scheduler running. So these are all running in the Kube system namespace. We don't have any pods at all in our default namespace yet. Okay, next thing we want to do is to start up the Cilium network. And to do that we need to find out what port the etc daemon uses or connects on. So we do kube control describe pod and kube. We need to tell Kube control that we are interested in the name Kube system namespace, and then the etc daemon. And by looking through this information, we find that the etc daemon uses the port number 2379, and that was actually what we needed to know. 2379. So now we are going to download a Cilium description file, a YAML file. Whoops. Here it goes. We get Cilium examples, Kubernetes, Cilium YAML. It was saved to Cilium YAML.1 because there was already such a file here. So I will just remove the old one and move Cilium YAML, the one we downloaded, to the correct name. So now we need to open it up and edit it. We go down here and we find the etcd config in here and the endpoints definition. We need to set that to the correct port number, which is 2379, and then we're done. And we are ready to create the Cilium networking containers. Kube control create like this. And we can now, what happens is that Cilium sets up something called the daemon set, which is basically a pod that is spread out on all the nodes in the system, or all the nodes that one has configured Cilium to be spread out to. In this case we only have one node, but if we would have had more nodes, the pods would have been started up on those nodes too. So we will check this out. So this is the daemon sets. So it's already up and running, and it's ready, the Cilium daemon set. And we can get the pods. And here we can see the Cilium pod being up and running too. It's ready running, while the DNS pods are still pending and getting up and running. If we just wait for a while, they will come up and be ready as well. So now they are up and running, which means that the networking now works in this Kubernetes cluster. So to deploy some interesting demo here, since we only have one node, we need to taint the node or remove a taint from the master node. In a default Kubernetes setting, the master node is not allowed to run any real pods. It only runs the system pods. So what we can do here is that we write kubectl describe nodes for this master node named x86 generic 64, and we find the word taint in there, and we can see that it has a taint saying that in its role as a master it shouldn't allow any scheduling of pods onto it. We remove this taint with the following: kubectl taint nodes, and we can pick this name here, and then we pick this part here, and a minus sign, which means that we should take away this taint. Okay, so now it's untainted. We can again look for taints on our node, and we see that there are no taints. Great, then we can schedule stuff on the x86 generic 64 node. So what we do then is to deploy hello world example. It's pretty long, so I will just copy paste this command. This is run hello world, 2 replicas. We label it as a load balancer example, and we pick the image from gcr.io. So now if we do kubectl get deployments, we see hello world deployment up and running, and we can try to take a look at the pods too. They are already up and running, both of them, both of these replicas. If we add O-wide here, we will see where they have been scheduled, and they are both scheduled on the x86 generic 64 node. Okay, so what we need to do now is to expose this deployment as a service, as a Kubernetes service, and that we do with the expose command. Expose deployment hello world, and we expose it as a type load balancer. With the name my service. Okay, so now we can do services, and we see that this is up and running, and it's running on this port, or it has exposed that port. So now we can, if we just check the IP address of this machine, we have here now we're trying out this service from our host machine. And it actually responds with hello Kubernetes. So then we know this service is up and running and it works as expected. We can do get pods all namespaces to see that we actually have the hello world pods here running and the Cilium pod and all the other pods that we saw before up and running. So that's the complete demonstration of Cilium and Kubernetes. We will now take down the system. So we start with kubectl delete services my service. It's gone, and then we delete the deployment. They are gone. So then we just do kubeadmin reset. To take down Kubernetes completely, and we also make some systemd daemon reloads and restarting the kubelet. So now the system is down. Thank you.